Hey guys, welcome back. Houston Math Prep here. In this video, we're going to take a brief look at one of our continuous probability distributions called the standard normal distribution. We've covered the normal distribution under our empirical rule videos. Now we're going to look at one special normal distribution and a measure that we can take on that distribution called a z-score. So first, let's jump into what is a standard normal distribution. Well, we learned in our empirical rule video that a normal distribution is a bell-shaped distribution that is defined by its mean, mu, and its standard deviation, sigma. In a standard normal distribution, we have a very particular mu. That mu is 0, so we have a mean of 0, and we have a very particular standard deviation. That standard deviation is 1. So here's a graph of that standard normal distribution. We can see we have our mean here in the center of 0, and then we have listed out our count by standard deviation. So we have 1 above, 2 above, and 3 above, and then the same going in the opposite direction. 1 below, 2 below, and 3 below. So the idea behind working with the standard normal distribution is that when we standardize, we can compare two different normal distributions. So we can compare a measure of position, how unusual or how far away from the mean is a particular value on one normal distribution versus another. So the measure that we use to do that is called a z-score. And a z-score is calculated as follows. Z equals x, which is your actual data value, minus x bar, which is your mean, divided by s, which is your standard deviation. Now this formula is, of course, if you're working with sample data, which we often are, but it could also be written as x minus mu over sigma if you happen to be working with population data. It's exactly the same thing. So what a z-score tells us is how far away from the mean are we? So what we can notice down here in this chart is that we consider z-scores that give us a value between -2 and 2 to be usual scores, meaning data value that falls between -2 and 2 in our distribution. We consider those normal data values. Nothing is abnormal or unusual about those. And that connects us with our empirical rule that told us that on any bell-shaped distribution like this, about 95% of our data values should fall between -2 and 2 standard deviations from the mean. So those are our usual. That's where we expect most of our data to be. When we get above and below that, when we start to extend down to 3 standard deviations below or 3 standard deviations above, so getting a z-score between -2 and -3 or 2 and 3, those start to become unusual. Okay, so when we start to get data values hanging out in this region, they're still not crazy unusual, but things that are that far away from the mean are not really your usual data value. Anything that falls outside of that window, outside of that 99.7% of our data should fall in here, or something that has a z-score of above 3 and below -3, we would consider those very unusual. In the next video or two, we're going to look at how can we use z-scores to determine if a data value is unusual, and also how can we use z-scores to compare data values from two different distributions to talk about which one is better or which one is more unusual. Until then, we'll catch you in the next video.